Okay, so we're going to continue on with this right triangle trig introduction. And we're going to do something with special right triangles and special angles. And so we're driving the point about trig ratios being specific to angles, but not to the triangle themselves. So we get a lot of these ratios from the triangle, but they're not fixed to that specific triangle. If the triangle gets bigger or smaller, as long as the angle stays the same, the trig ratio is going to stay the same. And so we have two special triangles called 45, 45, 90 triangles and 30, 60, 90 triangles. And three angles that are special, 45, 30, and 60. We're going to use those angles and these triangles to come up with knowing what the trig ratios are for these three angles. So we're going to try to fill out this table and know what the sine, cosine, tangent, cosecant, secant, and cotangent are for these three angles off the top of our head without using a calculator. And so that's what we're going to try achieving here. Eventually, what we're going to do is build up to being able to know the sine, cosine, and tangent of a lot of angles without a calculator. And this just helps with, these are very frequent angles that pop up in like math applications of trig a lot. And so knowing it off the top of your head helps you solve problems a lot faster without having to go to your calculator each time. It's kind of like how you know that like 1 + 1 is 2 without having to type it into your calculator. It's kind of what this is driving us towards. So again, this is more of the basic introduction stuff. You're not going to be expected to fully know it right now, like for all the angles, but we want you to start learning it for 30, 60, and 45 right now. And then we'll be able to build up on that later on, and especially next year. So we'll start off with the 45, 45, 90 triangle. So that means that you have a right triangle, that's the 90, with its other two angles being 45 degrees. When you have angles that are the same, the sides opposite them are also the same length, which means if this side length is x, then this side length is also x, because both of them have 45 degrees as the angle opposite. When you have that, we know that the hypotenuse follows the Pythagorean theorem, which means that the hypotenuse squared is x squared plus the other x squared, so 2x squared. And so if we just want the hypotenuse, we take the square root. Well, I know the square root of x squared is just x, and then square root 2. So I know the hypotenuse is x square root 2. What this means is, if I know that my triangle is a 45, 45, 90 triangle, and I know that, for example, this is 3, then this is also 3, and this is 3 root 2. Or if I know that I know this is a 45, 45, 90 triangle, I know that my hypotenuse is 4, I know that's x root 2, which means x is 4 over root 2. So this would be 4 over root 2, and this would be 4 over root 2. So it's a quick way of getting the other side lengths without having to go through the whole theorem for it, or without having to use any outside stuff. It's just fitting it into this pattern of x, x, x root 2. The 30, 60, 90 triangle, I'm going to give you the pattern, but this one I want you to think about yourself on why this pattern works. But 30, 60, 90 triangle means you have a right triangle with a 30-degree angle in it and a 60-degree angle in it. We're going to call the side opposite the 30 degrees x. That's the smallest side because it's opposite the smallest angle. The hypotenuse is opposite the biggest angle in a right triangle. That's why it's always the biggest side, because the 90-degree angle has to be the biggest angle in a right triangle. So the smallest side, that's going to be x, opposite the 30 degrees. Opposite the 60 degrees, that's going to be x times the square root of 3. And the hypotenuse is going to be 2 times x. That's the pattern here. So for example, if I know that I have a 30, 60, 90 triangle, and I know the side opposite 30 degrees is 5, then I know the side opposite 60 is 5 root 3. I know the hypotenuse is 2 times 5, or 10. That's how these ratios are going to work. So the ratios are fixed for these triangles with these angles. So as long as you have a 30, 60, 90 triangle, it's always going to follow this pattern. As long as you have a 45, 45, 90 triangle, it's always going to follow this pattern. So now let's use that to actually come up with these trig ratios for these angles. So for a 30-degree angle, I know that opposite 30 is x. This is x root 3, and this is 2x. So the sine would be x over 2x. Well, the x's will cancel, and you'll just get 1 over 2. So notice how it didn't matter how big this triangle is, right? X could be anything. X could be 0.2. It could be 100. This triangle could be really big. It could be really small. But because it's following this 30, 60, 90 pattern, the ratio is always going to be 1/2. Because I used x's on it, and that's what ended up happening. For cosine, that's going to be adjacent over hypotenuse. Again, the x's will cancel, and you just get root 3 over 2. Tangent will be opposite over adjacent. X's cancel, you get 1 over root 3. For the cosecant, we take the sine and we flip that fraction around. So you get 2. Secant will be 2 over root 3. And cotangent will be root 3. Let's do the 60 degrees since that's on the same triangle. So 60 degrees, now the opposite is x root 3. Hypotenuse is 2x. X's cancel. For the cosine, it's x over 2x. The x's cancel again. And for the tangent, it's x root 3 over x. X's cancel, you just get root 3. For cosecant, secant, and secant, and cotangent, we'll reciprocate all the fractions around. So you get 2 over root 3, 2, and 1 over root 3. So notice between the 30 and 60 degree angles, while we're trying to remember these things without a calculator and just know them off the top of our heads, there's a lot of patterns here. So the sine of 30 degrees is the same as the cosine of 60 degrees. That should make sense because when we drew our triangle, we got these ratios from the same triangle. The only thing that changed is which angle we were looking at. So that just changed which side was adjacent and which side was opposite. So on the 30 degrees, the opposite side was the x. On the 60 degrees, the opposite side, the adjacent side was the x. And so that's why you ended up with the same ratio here. And that relates to having the cosecant and secant be the same for each of these. The same thing happens for looking at the sine of 60 degrees is the same as the cosine of 30 degrees. Just as the secant of 30 degrees is the same as the cosecant of 60 degrees. And then lastly, tangent and cotangent are the same, cotangent and tangent are the same. Right, so all of those ratios, all we did was change which side was adjacent and which side was opposite on this triangle. So those ratios match up a lot. The other one is looking at the 45, 45, 90 triangle. So in that one, 45, 45, 90, x root 2. So opposite over hypotenuse is x over x root 2. It's 1 over root 2. Same thing for adjacent over hypotenuse, 1 over root 2. And then opposite over adjacent is just 1. And then flip all these fractions around, and you get these ratios. A lot of times, you'll be told that you can't have square roots in the denominator. That's not something we're going to force you to have for this year. It depends on your teacher and on your class. So depending on that, you might need to rationalize this. A lot of times on the internet, if you go and look this stuff up, instead of 1 over root 2, you'll see it written as root 2 over 2. This one you might see written as root 3 over 3. There was a time where it was very widespread that you should not have square roots in the denominators of your fractions. That's not so much a hard and fast rule right now. And so I don't mind if you leave those square roots in your denominator. When you do these ratios, you can remember it this way. But just remember, mostly if you look at this stuff on the internet or use a textbook, like even your current textbook, you're not going to see 1 over root 2. You will see root 2 over 2. And that's the same fraction. And we can go over rationalizing if you need more help on that. We've done a little bit in class, but not too much. So if you want a little more help on that, I can talk with you individually, or I can just make a separate video on rationalizing if a lot of people asking questions about it. But now that we have these are ratios we want to remember and just know without a calculator. We can use that to solve problems. So for example, on this one, we can do this two different ways. It gives us a triangle. We want to find the value of x. So one way we can do this is we know this is a 30, 60, 90 triangle, which means the opposite of 30 degrees is, I'm going to use a because x is already used. Opposite to 60 is a root 3, and the 8 is 2a. So if I know 8 is 2a, that means a is 4. And that means x has to be 4 root 3. If I do it, I can also do it using trig ratios. So I know the hypotenuse and I want to know the adjacent side. So the thing that relates adjacent and hypotenuse is cosine. So I can say cosine of 30 degrees is adjacent over hypotenuse. Well, I know the cosine of 30 degrees, looking at my table here, is root 3 over 2. And so I can solve for x. I can do the cross multiplying thing we looked at last chapter, right? In this case, I'm not going to cross multiply because I don't need to get everything out of the denominator. I just need to get the x by itself. So I'm just going to multiply by 8 on both sides. And then that gives me 4 root 3. So same answer both ways. Either you remember the pattern and then just go from there, or you remember the cosine, which you could do just by remembering the pattern or by remembering this table, and you'll get the same answer. But it's a way to solve for these values without knowing that much information about your triangle. Because like in these previous problems, I had to tell you at least 2 of the side lengths to be able to solve these problems. But now I can just give you 1 side length, and you should be able to tell me the rest of it. You will have to use calculators at some point as well, so you should know how you type those in to your calculator. So let's look at this last one. So we know that we have a 28-degree angle here. We know that this side, the adjacent side, is 15. We want to know the opposite side, and we want to know the hypotenuse. So to start off, we know the adjacent side, so we'll just pick one of them, either choose the hypotenuse or the opposite. Let's find out what the opposite side is. So to find opposite, the thing that relates opposite and adjacent is tangent. So now the tangent of 28 degrees is going to be the opposite side over the adjacent side. So then to solve for a, it's going to be multiply by 15 on both sides. And then type this in your calculator. So when you type it in, make sure your calculator is on the correct mode. Sometimes calculators can go into radian mode. You want to make sure this is degrees. We're looking at 28 degrees. And so that's going to be tangent 28. Type that in, and you should get 0.531. And then multiply that by 15. And you'll get 7.976. So that's the opposite side. Next thing to do is find the hypotenuse. So to relate adjacent and hypotenuse, that's the cosine. So do cosine of 28 degrees. And that's going to be adjacent over hypotenuse. In this case, I multiply by c on both sides. And then divide by cosine to get c by itself. And I type this in, so this would be 15 divided by the cosine of 28 degrees. And that gives you 16.989. So we can use these trig ratios to solve these triangle side lengths, just knowing which side is opposite, adjacent, and the hypotenuse. So that's going to be it for this video. We'll do one more video. That one's going to be a shorter video just on the types of word problems you get with this.